What is going on, guys? Welcome to today's video. So in today's video we will be performing an attack on my older computer on my network. So essentially a good way of thinking about this attack is, let's say you are on public Wi-Fi, let's say you're in a coffee shop or you're at a hotel and you are beside a malicious hacker, someone that's dying to get your Twitch logon credentials, and you're ready to, sit back, maybe watch your favorite streamer and type in your logon credentials into Twitch. Now, this attacker has been waiting for some odd time for you to type these logon credentials, and once you do enter them, he captures them, and now he has your logon username and password. So for this video, I'm going to first explain how the attack works at a high level. I'm going to explain the different types of attacks that we're using here, and then we're going to perform a demonstration. I'm going to be entering the credentials on my older Mac here, an Intel chip Mac, and then we'll be performing the attack from my newer M chip Mac, and we'll be using a TP-Link Wi-Fi adapter in order to perform this attack. And at the end of the video, I will provide some ways to prevent this from happening to you, so you don't have to stress out about someone stealing your logon credentials, even though it's highly unlikely, but it's good to be aware of this attack and know how to prevent it. So here we have our target here, we have the attacker, we have our router, we have our internet service provider, and we have this globe here which resembles the internet. So essentially in normal traffic or normal networking scenario, let's say you're in this target here, this guy over here is in his home and he wants to send traffic out to the internet. He's first going to send it to his router, and his router will then send it to the internet service provider, which will send it to the designated location on the internet, and then it will go back to the target through the router. So our goal here is to put ourselves in between our target here and the router, so we can capture all traffic going out to the internet and all traffic coming back from the internet to our target. And how we're going to do this is we're going to take advantage of not a misconfiguration, but when they developed or when they created the ARP protocol, they didn't really take in security into account. They wanted to make it as efficient as possible. So we are going to take advantage of that. So how we're going to do that is we're going to tell the target here, we're going to send an ARP response, which essentially tells the target that we are the router. So the target now is going to think we're the router, and it's going to send all traffic that it would normally send to the router to us. And we're going to send a very similar message to the router here, which is going to be an ARP response, and the router will then think that we are the target. So this effectively puts us in the middle of the connection, because the target here thinks we're the router, so it's going to send all of its traffic to us first, and then the router thinks we're the target, so it's going to send all of its traffic to us, and then we're going to forward this traffic back and forth between them. When someone types in, let's say we have our target here, he wants to visit Twitch. So he's going to type in twitch.com, and in his browser, he doesn't actually prefix twitch.com with HTTPS. So by default, it's going to send that message, or you can say that request, to the server in HTTP. So that is non-secure. You can read the plain text information for that request. And now the server is going to see that, and it's going to say, hey, I actually prefer to communicate securely. Let's establish a secure connection. So it's going to send a message back to the router, and then back to us, and then back to the target. But where SSL stripping comes into play is our target here, our attacker, is going to see that this response is in HTTPS. And it's going to strip down the response, and it's going to convert it to an HTTP response, so a non-encrypted response, and it's going to send it to our target here. So now our target is going to have an HTTP response, and he's going to send back an HTTP request. So essentially what's happening here is our attacker is establishing an HTTPS secure connection with the web server, and every time the target here wants to communicate, as it's the one initiating these requests, it's actually sending everything in HTTP. This target thinks it's communicating to the web server in HTTP, but it's really communicating to the attacker in HTTP, who's continuously stripping down the secure connection, and then he has his own secure connection with the server. And this is a perfect situation for the attacker, because The server is happy because the server has that HTTPS encrypted connection with the attacker, and the attacker is happy because he can read all the traffic because he's the one who has established that secure connection. So he has the keys to decrypt everything. And this target here just thinks that he's speaking to a server that prefers HTTP. All right, guys, so at this point, we've discussed the two main portions of how we are going to conduct our attack of capturing login credentials. So now it's time to do the demonstration. All right, guys, let's get straight into it, the attack now. So to start off the attack, we want to start off with our ARP spoofing, as we mentioned earlier in our explanation. So for our ARP spoofing attack, we're going to use a Python script. So we're going to use this ARP spoof script here, and we're just going to use this command I used earlier. This is the IP address of my target here, which is my old MacBook computer, which is the machine that we want to attack, and then this is our router. So if you remember from earlier, we want to place ourselves in between the target and the router, and this is essentially why these are our two input commands here. So as we run the script, we're going to continuously send ARP response packets to both of these addresses to make sure we stay in between this connection here and are able to intercept the packets. So for our next program we're going to run, we just want to essentially capture the data that's going through our wireless adapter that we have connected to our computer. So we know we're in between this connection, and we just want to print out the data that's flowing through from this target machine through our computer to the router. And specifically, we're just going to print out the HTTP layers here. So this packet sniffer, it looks at the traffic that's going through our computer from the target to the router, and it filters only the HTTP data. So I have this command run from earlier here, and we're going to use the wireless interface WLAN 0 here. And just to show you here, this is our WLAN 0 interface. So now we have our sniffer running here, and it's time to run the SSL stripping attack. So we're going to use BetterCap. BetterCap is the Swiss Army knife for these types of spoofing attacks, and it is developed in Go. So here we're using the interface here, the same wireless interface, and we're using the HSTS hijack caplet, which essentially is the basis for our SSL stripping attack. So we're going to run that, and now let's go to our target computer. So now we are on my older MacBook Pro, the machine we're attacking, and I just want to show you guys that this is the exact same computer we are attacking. I'll show you by displaying the IP address. So here you can see we have the same IP address we entered earlier for the target. So now let's run kind of the part that you guys have all been waiting for, the part where we actually capture the credentials from logging into Twitch. So here we've entered Twitch, and as you can see, already the connection, the HTTPS, has been downgraded to HTTP, which is exactly what we want. Something to note here is the actual time it takes for this to load is a decent amount longer than the typical time you'd wait for a page to load. So if you are, let's say, in a situation where an attacker is attacking you, you may seem suspicious. Why is a page that you visit all the time taking so long to load? So it's just something to note here. So here we've loaded. It says that they couldn't find any recommended channels, which is not a problem. We could browse channels, but for the sake of time, let's go straight into our login. So I'm just going to enter some random login information here. And press login. We won't save here. And as you can see in our SSL stripping here, we have our username, Vic Doesn't Bite, and our password here, like and subscribe. I botched the spelling here. But yeah, you should like and subscribe if you enjoy the video, if it taught you something. It helps me out a ton. And yeah, so that shows in the stripping how we captured the credentials, which is pretty awesome. And then if you refer to our sniffer here, which is just capturing traffic through our interface, we can see our username and our password as the login parameters here. All right, guys, let's talk mitigation. So let's say you're a little bit stressed or you're not sure how to avoid this attack happening to you. So essentially, I'd say this attack is one of those things that you'd probably notice if it was happening to you. And for the reason being is you could see in the actual walkthrough that it took quite a while for twitch.com to actually load. That would be something that you'd be suspicious of. Also, if you're slightly aware of like how HTTPS and HTTP works, you may not be. I wasn't either before I started getting into cybersecurity, but it is a good thing to look out for that padlock in the top left corner, like right next to your URL. I would say majority of websites now, especially big websites like Twitch and Amazon, have or essentially require HTTPS encryption. So those are two good things to look out for. If you do see some of those things, you should be suspicious that an attack is happening. Another thing to prevent this attack from happening is, if you remember in the SSL stripping explanation, we actually sent that first request we sent, the first HTTP request for twitch.com was not encrypted, and that's just the nature of how the browser works. If you just type in twitch.com, it'll just first send an HTTP request, and that actually allows the attacker to control the encryption between the secure encryption between the server and the attacking machine and the target. But if that initial request that the target sends is actually HTTPS, or if it's encrypted, then the attacker has no way of performing SSL stripping. So to essentially force that first request to be HTTPS, you can use HSTS security, and some of the major websites like Facebook, Amazon, like those websites actually have HSTS built in. So it's built into the browser. So the browser actually won't allow you to send Facebook with an HTTP request. It'll only allow you to request the Facebook domain with actually HTTPS requests. So that's a built-in security. So if let's say you could apply HSTS to your website, but that's really not reasonable for someone to do. That's something that you'd probably have to work at a company or understand how all that stuff works. But something that is easy for you to do, and something that you could do and easily implement yourself, would be to use a VPN. So a VPN would actually encrypt that first HTTP request going out onto the internet. So this would make SSL stripping not possible in this situation. The last thing I want to mention is how possible is it for this to happen, like in a real situation. Like, let's say you're in a coffee shop or in the airport or in a hotel. How possible is it for like something like this to actually occur on a day-to-day basis? And the answer here is it depends. So I was doing some research, and Starbucks apparently segments their network. So their network actually isn't flat, and what that means is everyone on the network has their own private VLAN or subnet, and those people can't access anyone else on that local Starbucks network. They're only allowed to just communicate to the internet. So let's say I'm an ethical hacker, but let's say some malicious hacker came into Starbucks and they wanted to see if any other devices were on the network that they could possibly scan. Since Starbucks segments their network, that attacker won't be able to see any devices on the network, and they won't even be able to perform ARP spoofing. So it depends. If you go to a coffee shop where they don't implement any segmentation in their network, and maybe it's like a one-off coffee shop, it's not like a chain, then that could be different. It really depends on the situation. but it is something to look out for, and I hope you learned some stuff in this video. If it was helpful and you did learn some stuff and enjoyed the video, please do like and subscribe. It motivates me to post more videos if they do better. So I hope you guys have a good day, and I'll see you next time.